Hi guys, my name is Irvi and today we're going to do some data science.
Today we're going to be working on another variation of the Bayes rule problem. This one specifically is going to be about conditional probability, and we're going to be working on the Jurors problem. So let's start by reading the question. So we have a couple statements in the problem, and it tells us that jurors will make the right decision about guilt and innocence 60% of the time, and that 70% of all defendants are truly guilty. And so this variation of the question asks us to find the probability being innocent given being convicted, essentially, which means you're finding the probability of a convicted defendant being actually innocent. So a little quick jargon thing. A convicted defendant means that you are basically accused of your crimes and you have punishments of some sort, versus being innocent means you don't get any punishments of any sort. And then guilty and innocence, right? You either commit the crime or you don't commit the crime. All right, so for this variation of the problem, we're going to be using the table method. And we can start by drawing out a table. So we're going to put convicted right here. I'm just going to shorten it for C-O-N-V, and then we'll put acquitted. So convicted, again, means that you are punished for your crimes. Acquitted means that you are let go of your crimes, or you're found innocent of your crimes. And then we'll put guilty up here, and then innocent up here. Okay, and then we will draw these out. And then we'll go this way and that way. Okay, so now we have our table for the most part, and I personally like using whole numbers instead of the percentages because it just sometimes makes sense for people more. So we're gonna start out with having 100 total people, right? For 100% of something. And we'll put totals up here actually, in here and here. So now, the first thing we know is that 70% of all defendants are truly guilty, right? So if we look at our columns, right, we want to put that 70% value in one of these columns or sections right here, because this is the area that kind of combines both aspects of the problem. So essentially, we're going to see that 70% of all defendants being truly guilty will mean that we're going to look in the guilty column, and we're going to put the 70 right here. Yeah. So the 70 goes right here. And now we know that if there's 100 total people, that if there's 70 that are guilty, we're just going to do simple subtraction to find the number of innocent people, which is 30. So then from here we know that jurors are going to make the right decision about guilt and innocence 60% of the time. So I like to do a little shading of some sort. So technically, if you're guilty, you're going to be convicted. And if you're acquitted, you want to be innocent. So the blue is kind of like, the true ones, if that makes sense, right? So if we know that they make the right decision, right? This is our right again. We want to use the 60% value and multiply it by the 70 to find this particular section. So we're going to do 70 times 0.6 equals, what is it over here? It's going to be 42. And that's just multiplication. And now if we have 70 total guilty defendants, right? And we want to find the number of the 70 that are acquitted of their crimes, we can just do subtraction again. So 70 minus 42 will equal 28. And we have this value now. And so we can do the same thing for this side here. So we have 30 total innocent people, and if they make the right decisions about guilt and innocence 60% of the time, we'll just do multiplication again. So we'll get 30 times 0.6, and that'll equal 18, I believe. Yeah, 18. And then to find the last part of the innocent or convicted people that are actually innocent, we'll just do subtraction again. So we'll do 30 minus 18 to get 12. And then we have the values in our table here. But now we want to find out the total number of people who are going to be convicted and the total number of people that are going to be acquitted. And we can do that by just adding these values here. So then we'll have 42 plus 12, which is 54? 54. We have 28 and 18. We'll just add that again, 28 plus 18 here to get 46. Here, and then I'll just put 42 plus 12 up here. Yeah. So these are our values for our table. Now we have like the entire table. And from here now, we could look to find out how to actually find the answer to our question. So we have the probability of a convicted defendant being actually innocent. So knowing this, we really only want to look at our convicted defendant column because that's like the population, I guess, of this problem. And our convicted defendants are 54. So we know there's going to be a value over 54. So we'll just do 54, and then we have something up here. And then our something is the percentage of being actually innocent. And we have our actually innocent column right here, right? And that's 12. So we'll put the 12 up here. And then that's your answer. You can just put 12 divided by 54 in mastery platform. You don't have to actually like put the percentage in, especially if you're on a time crunch during your midterms and exams and whatnot. It's easy to just do this so that way you don't also have to mess with the decimal and stuff. So yeah, thank you so much for listening. I hope this makes sense to you guys. This variation and method of doing the problem can be applied to like the probability of like the cancer test one and to some extent like the COVID ones as well. So just remember making the table, looking at the keywords in the phrasing that you've given. You want to look for like truly guilty or keywords like correctly positive or correctly negative as well. And looking at these keywords to then input those values into your table and then just, doing some basic addition, subtraction, multiplication to find the rest of your table and then filling out the blanks and then finding the probability accordingly.